Let's take one more example to further elaborate this method of isoclines to construct phase portraits. We have this system given by these differential equations. First step is to write these equations in state space form, and you already know the procedure. By taking theta equal to x1 and theta2 equal to x2, you have this state space representation of this differential equation. What is next step? We write equations for isoclines, and this is equation for isocline dx2 by dx1, that is the slope of trajectories at given point. So that is dx2 by dx1, that is equal to f2 divided by f1. So f2 is over here, f1 is this one. We substitute this to be equal to alpha. So what is this equation? Equation of isoclines, that is equation which describes set of all the points in phase plane on which the trajectories will have the same tangent slope. So this equation this equation is rewritten over here. This is again an equation of a straight line. We shall draw these isoclines for different values of alpha. So let's take a few numerical values of alpha, and corresponding to those values of alpha, we draw the isoclines. I have taken some values in a particular way. Why in that way? Because that will help me to draw the lines very easily. So I have taken alpha equal to -2, and for this value of alpha, what is slope of this line? Slope of isocline, slope of this straight line. So it comes out to be equal to 1 by 2, 0.5. Here 1 minus 2 is -1, so that negative sign is cancelled out with this negative sign. So slope comes out to be equal to 0.5. I have written it in another form because I do not have a protector with me. I want to draw it simply with scale over here. So this is a phase plane. In this phase plane, I want to draw isocline corresponding to alpha equal to -2. So simply this line with slope 1 by 2, how to draw it? So I have placed one at here, 1 point, and this point on vertical 1 box, on horizontal 2 boxes, to get us a line with slope equal to 1 by 2. So draw this line. This is line. On this line, what is slope of trajectories? That is alpha is equal to -2. So next I take another value of alpha equal to -3 by 2. Again I have taken this value so that it is easier for me to draw the lines, to draw the isoclines. For alpha equal to -3 by 2, slope of this line, that comes out to be equal to 1. So simply by substitution of alpha equal to -3 by 2 over here, this thing comes out to be equal to 1. So I can easily draw a line with slope equal to 1. So if you are not convenient with this thing, you can use protractor to draw these angles. For alpha equal to -3 by 2, slope of this isocline, this straight line, that comes out to be equal to 1. I place this scale over here. One slope means vertical box 1, horizontal box 1. So this line will have slope equal to 1. Yes, you can do it. You can also proceed in that way. Corresponding to that alpha, you determine the angle of the line and draw that particular line using protractor. So I have drawn it over here. alpha equal to minus 3 by 2. Remember that this alpha is not the slope of line. What is alpha? Alpha is the slope of trajectories which will be passing through these lines. So similarly, take other values of alpha. I have selected these values so that it is easier for me to draw these lines. You can of course take some other numerical values as well. For alpha equal to minus 5 by 4, slope of this isocline that comes out to be equal to 2. Again, I can draw this line. This line has a slope equal to 2. Vertical box is 2 and horizontal box 1. And on this line, on this isocline, all the trajectories which will be passing through this isocline will have a slope equal to minus 5 by 4. This alpha equal to minus 1, that generates the slope of this line to be infinity. What is that line? Vertical axis. So here is that line, and on this line all the trajectories which will be passing through this line will have a slope equal to minus 1. Similarly, alpha equal to 0 corresponds to this line. How to draw this line? Minus 1 by 2. So one box vertically and two boxes horizontally, but horizontal box in negative direction, right? So this line, we have two boxes in negative direction and one box in this vertical axis. So on this line, on this isocline, all the trajectories which will be passing through this isocline will have a slope equal to 0. Similarly, for alpha equal to 1, we have slope of this line comes out to be equal to minus 1 by 4. How to draw this line? 4 boxes in this horizontal direction with negative in negative direction, and one box in vertical direction. So this is line, and all the trajectories which will be passing through this line will have a slope equal to 1. Alpha equal to 2 corresponds to this line, and that is sketched over here, and alpha equal to infinity corresponds to a line with slope equal to 0. So what is that line? On the horizontal axis, so this is line. On the horizontal axis, we have all the trajectories which will be passing through this isocline will have slope equal to infinity. So I have drawn some isoclines. These values of alpha were chosen so that it is easier for me to draw this line, these lines. If you are not feeling convenient with that one, you can simply take some numerical values, equally distant numerical values of alpha, and use protector. So I wanted to get rid of protector. So for me it was more convenient to think about numerical values of alpha so that the slope of the lines will be such that I can draw these lines easily. So if you do not feel convenient with this one, simply take some numerical values of alpha. For example, start from minus 2, and then you will of course would like to take minus 1.5, minus 1, 0, 0.51, and so on in that particular way. Corresponding to that alpha, determine the slope of these isoclines, use protector to draw those angles. Is it clear? Since I have selected these values of alpha which were not equally spaced, therefore the isoclines which I have drawn over here, these are also not equally spaced. So let's draw some lines over here as well, the empty space. So how we should choose the values of alpha? For example, if I want to draw one more line over here, slope equal to, for example, this vertical box, 3 vertical boxes and 1 horizontal box, that comes out to be -3. We take slope equal to -3, and corresponding to that slope we find the value of alpha. So you can proceed it in this way. So I have taken these slopes -1, corresponding to that alpha came out to be equal to -1/2, and another value of slope -2, and alpha came out to be equal to this one. This slope equal to -3, and alpha comes out to be equal to this one. Why these values? Because these are easier for me to draw with simple scale. For example, this line, slope line with this slope, how to draw it? This vertical box, 1 vertical box and 1 horizontal box in negative direction. So I shall, one point is over here, another point here. So draw a line joining these 2 points. And on this isocline, the slope of trajectories will be -1/2. Similarly, draw this line with alpha equal to -2. So that will be obtained by joining this point and this point. So that line is over here, and one more line, slope equal to -3. So now I have a sufficient number of lines, and I can just use these isoclines to draw phase portraits for a given initial condition. So any question up to this point? Yes, you will get a grid, and on using those grid lines you will be able to draw the phase portraits. For more is the number of lines, more is the number of isoclines, more accurate will be your graph, and less is number of isoclines, it will not be a smooth graph, as we have seen in previous example as well. So let's draw a phase portrait for this initial condition. So how should I move? So previously what we were doing is that from here to midpoint between these 2 lines, we were moving with slope equal to this -1. So this creates complexity, as there was a question. So let's prefer simplicity over accuracy. We move from this line, this isocline, to this isocline with slope equal to -1. So that it is simple for us, right? Of course, it will be at the cost of accuracy. So let's draw this phase portrait. So how should I move? How to draw a trajectory with slope equal to -1? For example, 1 box downwards and 1 box in this way. So that is will be this point and this point. Joining these 2 points, we shall get a trajectory with a slope of -1. So here, this line sketched over here, this line. So how should we proceed further? -5/4. -5/4 means if I want to draw this line with the help of scale, how should I draw it? 5 boxes in vertical direction and 4 boxes in horizontal direction. That is, this scale now has slope equal to -5/4. 5 vertical boxes. If I count from this point, 1 box, 2 box, 3, 4, 5 boxes. 5 boxes downwards and 1, 2, 3, 4. 4 boxes horizontal. So this scale has a slope equal to -5/4. I just move this scale over here and draw a line. So scale moved over here, draw a line, and we have similarly we can proceed further from this point to this point, how should I draw a line? Minus 3 by 2. So you can verify that this scale now has slope equal to minus 3 by 2, right? And now from here to this isocline, slope with minus 2. Is it clear? And proceed it further, slope from here, from this isocline to this isocline, what is slope of trajectories? Infinity. And from here to here, what is slope? Slope equal to plus 2. From here, this isocline alpha is equal to 2. So from here to here with a slope equal to 2. So slope equal to 2, this scale has a slope equal to 2, and then draw a line over here. And then proceed it further from here to here with a slope of alpha equal to 1. Proceed it further. So this isocline, on this isocline, where is slope of trajectories? Alpha is equal to 0. We have drawn a horizontal line, and then we have proceeded it further. For example, from on this isocline, what is slope? Slope is equal to, slope of trajectories is equal to minus 1. This scale has a slope equal to minus 1, and then move it over here and draw the lines. So you complete it. So this is a rough sketch of phase portrait. It is not a smooth curve. However, by looking at this graph, you are able to qualitatively describe the behavior of this system. So what is behavior of this system? It is a focus. If you draw more lines, this spiral will finally converge to this equilibrium point. So the equilibrium point at origin is a focus, and there will be oscillatory response of the system. Yes. So yes, you can also proceed here. It will be a growing curve. So over here, we are not sure whether this is a stable focus or unstable focus. Why? Because the direction of arrows is still not known. What is direction of arrow? That is not known. So we are not sure whether it is a stable focus or unstable focus. Direction of arrow can be determined in different ways. One simple approach is that, what is x2 on this horizontal axis? 0. So on this horizontal axis, x2 is equal to 0. It means that what is x2 dot on this horizontal axis? What is x2 dot? X2 dot x2, this is 0, x1 is positive, so x2 dot is negative number. What is meaning of x2 dot to be negative? What is direction of trajectories? Change in x2 is negative, right? It means that around this point, change in x2 will be negative. That is, what will be next time instant? This one. This is next time instant. So direction of arrows at this point is downwards. That is, it is a stable focus. So we shall also talk about some other strategy to talk about whether it is a stable focus or unstable focus. Yes. So more is the number of lines, more accurate will be the graph. So over there we stated that we move from this point to mid of these points. that is equivalent to sketching one more isocline over here. So more is number of isoclines, more smooth and accurate will be the graph. And however, that will be at the cost of more computations. Anyway, the objective of presenting this approach was to give you an insight to that approach. In practice, you will always be using MATLAB and other computer algorithms to plot phase portraits. So as an assignment, you have to utilize method of isoclines to draw phase portrait for this nonlinear system. So just a hint how to handle this nonlinearity. You can split this equation into two equations, that is for x dot greater than 0 and x dot less than 0. So for x dot greater than 0, you have this equation, and this written in state space form is given by this relation, and for x dot less than 0, you have these state equations. That is, in the complete phase plane, the upper half of the phase plane over there, isoclines will be given from this equation, and in the lower half of the phase plane, isoclines will be given by these equations. So you draw isoclines for the upper half of phase plane, you draw isoclines for lower half of the phase plane, and then for a given initial condition, draw the trajectories. So you have to use this method of isoclines to draw phase portraits for this system, and then you have to verify your plot by using MATLAB. So remember that this approach becomes more complex when you have a highly nonlinear system. The example that we considered in previous slide, that was example of a linear system. That was a linear system. That is why the isoclines were described by straight lines. This is also somehow can be split into two linear systems. This is also easier. However, if it is some nonlinearity is there, for example, here we have x squared term, that x squared term will appear over here, and in that case, equation of an isocline will not be a straight line, and then you will have more complex situation. However, for those complex systems, we shall always be using MATLAB to obtain phase portraits.